Okay, so that's our agenda. We'll do a quick overview of some of the more important services that you would probably like to start experimenting right away, right after this webinar. That would be probably the ideal situation. A while back, Sir Arthur C. Clarke formulated this principle, which was later on added as a third law. Any sufficiently advanced technology is indistinguishable from magic, and this is true to what is happening with machine learning. It's no longer just linear regression or maybe classification using naive bias. It's more of neural networks, and those systems have been commoditized so that companies like Google, Amazon, Microsoft, who invest hugely in research and development can really share it with the rest of the population. So this is the list as of early in 2019 of all the services which are categorized as machine learning. We're going to touch on some of the which are at the top. They are adding those new services at the bottom, like hotcakes, like personalized forecast extract. It's like smart OCR type of things, recommendation systems, collaborative filtering, and all those things, they are ready for you to use right off the bat. It's sort of like off-the-shelf software. You can have, I guess, bidirectional communications through some sort of web services, and you don't need to invest anything, a penny, out of your on-premise fixed cost outlays. You can just get an account with Amazon to start using those services. We'll start with the actual machine learning component called the SageMaker. It's just one word. It targets data scientists and developers, and it supports the full cycle of machine learning or data science projects, starting with getting the data, feature engineering, labeling, and then building a model and deploying it in production. It's just end-to-end support. You can develop your own algorithms. That is the primary target, but at the same time, you can leverage whatever people have invested in developing. And there is a machine learning algorithm marketplace that Amazon offers to you, where third-party companies who have heavily invested in machine learning research can, I guess, monetize the investments by way of asking you just for a fraction of the cost of the initial investments. So that's what I guess makes it very interesting. So you pretty much walking into this Costco-like type of warehouse, and you start selecting, picking and choosing the algorithms that would best suit your needs. And it will cost you definitely just a fraction of the cost compared to what you would have had you decided to go and doing it on your own. So SageMaker, as I said, supports the full cycle of data science projects. In terms of relationship between data science and machine learning, data science is a bigger thing, which encompasses machine learning as just one of the discipline that is part of data science ecosystem. So you start from the top, you get in the data, data might arrive in real time, or it might come usually through some sort of ingestion process. Probably it will be S3 storage, that's object storage. You clean data, you would probably apply all those initial steps that are relevant to machine learning projects, such as fixing missing data, maybe just generally scale your data and transform data, perform data feature engineering, and dropping certain features, basically preparing your data to be used for training your machine learning algorithms. So at this point in time, I guess the fun begins at that kind of a bottom of the circle, you train your model. You select your model, whatever the case might be. It can be supervised, unsupervised learning. And then you would evaluate your model, see how it behaves using some knobs, dials, hyperparameters like learning rate and maybe some loss function parameters, so that you can, I guess, achieve a very good result. What's not shown here, but it's also present. So this, I guess, diagram doesn't give you the whole picture, but definitely training is very important. Right, but at the same time, you need to test your model. You don't need to test it in production right away. You don't need to put it. So you would need to test your model when you do the evaluation against your test data. So there should be some holdout data that you use for verifying the model. So if your data is representative enough and you have enough of data, then the best outcome is that your model behaves very nicely for the training and for testing. It's not overfitting, it's not biased, and at the end of the day, at the bottom of this kind of hour, you say, yes, our model is ready for deployment in production. And at this point in time, it's absolutely painless. It's just a matter of moving your model that you would probably serialize into some sort of supported form. It can be a pickle it can be a jar file, pickle for Python, it can be a jar file, and that would be your model serialized and ready to use in production. So you would put it on the servers, which are powerful enough, which are scalable, and you're ready to go. When you deploy the model, in the same environment as where you were doing the development, just different stages. Like you've got system integration testing, kind of a UAT, and production, pre-production testing and rollout. So you start monitoring, collecting data. Again, it's just not the whole picture, it's just full cycle. But here, what it says is that you potentially can capture the data that you get from the client in the cloud and start feeding it as training data, so that you would be able to fine-tune, improve the accuracy of your model altogether. Okay. So SageMaker, as I said, is a real machine learning system. It supports all the frameworks that you would be able to get your hands on. So it supports Jupyter notebooks. That's what most people do. But the good thing about this is that those are backed up by fully managed instances, meaning that you have extremely powerful machines that would allow you to have 64-bit type of projects with terabytes worth of data being processed. Apache Spark, those people who are in love with that system can also find support from SageMaker. So we've got Scala, Python for Spark, and generally what people prefer doing is to use Python. Python, of course, doesn't give you the runtime performance compared to Scala, which is Java-based system, but in many cases it's not relevant anymore because you have very powerful machines with lots of memory. Things are happening in memory. And with Python, you have much faster data science project cycles. Your velocity is much higher, as opposed to maybe using Java-based languages like Scala. Okay, so that's the whole process that I mentioned. So SageMaker supports wall-to-wall processing. So you start with your model, and you would be able to train it and then deploy. So everything happens from top. It's not, again, you cannot read, you have to read through the lines, between the lines. So essentially, client would eventually start asking for some predictions, for inference of your model. The output that your trained model would intelligently output, whether it's classification or whether it's some sort of continuous variable output. So ground truth is the labeled data that I guess they should have separated. This slide is borrowed from Amazon. And the point here is that there would be an endpoint through which you would be able to feed your labeled data for classification or for regression. And that data would be ingested through S3. S3 is a very popular system. You can have command line API. You can build very nice workflows. At this point in time, by the way, one of the mechanisms that you can use is Lambda. So Lambda, it's kind of a function which runs on demand. It's a very efficient way. Just don't use like EC2 instances. Use Lambda. So whenever you see some demand for integration, look for lambdas. So you get the data, and at this point in time, I guess your data would be used for training. You would start developing code, and your code could be serialized into this EC2 container registry, where it could be serialized as a Docker container. Lots of, I guess, engineering effort would come here. So that's the real data science project. So machine learning is happening when you do the training, right? But around that thing, around that centerpiece, you have lots of things that might happen seamlessly and transparently, so that you know where things are happening. So you have probably looked at this and you're thinking, so it looks like there is a lot of complexity into it, and you're right. If you really deploy a very large machine learning system in Amazon, probably it will cost you a little bit more than you would expect. So exercise some constraint, see where you can probably cut on the cost, because every bytes that you move around, every hour or minute of that CPU that has been used to produce the results would be billed to you. You would be paying for what you're using, and your appetite comes as you eat. So as much as you can, so that's kind of a word of caution, as much as you can perform some initial training, initial understanding of your data on premise. Probably your laptop has 64-bit architecture, and probably you have 16 gig of RAM. That's enough for you to do very meaningful processing of maybe several millions of records or examples, observations, whatever the term comes first to you. And then when you're ready, deploy it in Amazon. So what you can really enjoy is that Amazon gives you specially designed systems like P3 instances, which come with GPU support. So graphics processing units like NVIDIA processors, which are highly optimized for linear algebra type of things. And that's what I guess training is all about. It's about matrices being multiplied. You do inversion, transposition, and all that stuff. It's much faster to be done, not on CPU, but to be done on video cards. Right, so you have pretty kind of a powerful systems with lots of CPUs, lots of RAM per GPU, and all that comes, of course, at a price, but that price would definitely be just a fraction. If you have already done your due diligence and you have already arrived at a point where you have a perfect understanding of your data, it's just a matter of you, I guess, run it as fast as you can, because some machine learning algorithm might take you, I don't know, hours to maybe, if not days, to get done. But it will be probably a matter of several, maybe up to $100, but that would be quite cost efficient. Okay, so you need to do this balance between what you can do without incurring that bill, which would be sent to you by the end of your billing cycle. So there is a question. Okay, last slide may have a typo, from or from. Or probably yes. Volumes, form. Perfect. So which pretty much tells that Dana, thank you very much. It looks like you have that eye of the eagle, and you're looking at the spec, which is a good thing. You're looking at the spec, meaning that you're interested. Thank you very much. So comprehend, it does what the name suggests, natural language processing and text analytics. Of course, you can do it with Perl, you can do it with Python, and many people are rolling out things as if there is no tomorrow. But in fact, at a certain point in time, you would probably reach a point where you would say, we cannot really move things beyond a particular threshold. We have reached a level of entropy where we cannot really get things reduced. We pretty much have a not maybe a black box of what that text is or that document, but probably some shade of gray. So what you can get is some linguistic artifacts. Your text that you would upload through some sort of web service, you can, I guess, post using the endpoint for comprehend, and you would upload a document of some sort. And the system would just parse it, and it would extract all the entities, such as nouns, all those assets around which you would probably build a narrative. And dates and key phrases, language would be detected, and sentiment. That's probably what people are after. They want to understand what it's all about. It might be feedback. You launch a new product, a new service, and this service is, I guess, people are following on Twitter or some other social media platform, and you would be just getting the data, fetching the data in real time, seeing what people are telling. And it's critical. The shorter that feedback cycle you have, the better. Right, your sentiment can be anything. It can be mixed, neutral, and definitely you're after positive, but negative if it's kind of it's productive. It's not just trying to deprecate, just flame the system. If people provide honest feedback, it would be very important as well. So the entities, the nouns, which would be extracted, would help you to understand. So you got the sentiment and you got the entities, and you pretty much understand what people are complaining. It might be part of the system. You might have a, I don't know, like you launched a new car or a new rather complicated system, and it has several parts. And you would be able to pinpoint what are people complaining, not about the whole system, but have a very kind of a narrow kind of a surface area of complaint, what people are really not happy about. So here's an example. This is Amazon Web Services Management Console. So when you log in, if you have an account, you would have very nice, responsive, in most cases, interface. It's a web UI where you can start experimenting. This is just, as I said, the dashboard console, but you can also do web service calls, request like post, and getting the results back. So here you see an example of the lyrics of Let It Be by the Beatles. And if you look at the input text, you cannot really get your head around. It's just, it talks about trouble, it talks about darkness and all that stuff, which would probably in a regular, straightforward, not very sophisticated system would say, this is negative. Okay, so, and pretty much you lost that good insight. But look at the embedded sentiment which comes as a response on that thing if it had been submitted through a web service. So it comes as a JSON document, which pretty much with accuracy of 72%, I like that kind of a decimal points. It just shows the precision, which probably doesn't really mean anything. I guess the first two digits would tell the whole story. 72% of that kind of a confidence of our comprehend is that it's a positive text, right? It's not neutral. Yeah, it can be neutral, but definitely it's not negative and it's not mixed. So the system probably applies some sort of a logistic regression, and it does this analysis, which is kind of a cool. Okay, so there is a question, does SageMaker provide out-of-the-box machine learning algorithm libraries? Yeah, they support MXNet, they support Keras, they support TensorFlow. Yeah, they do. Okay, so as you see, it's not the whole, it's just screenshots. At the bottom, you've got insights, entities, key phrases, language, sentiments, right? And it can be done in different languages. So English or American is not the only language on the Earth, on the planet Earth, right? So DeepLens. So we're switching gears, another system, right? So far we've looked at SageMaker. We touched on Comprehend, DeepLens, third service. How are we doing on time? We're good. Good. So as you see, Amazon has been very aggressive in this field. They're adding new services just as of late. Lots of things are in alpha, not even beta. And things are just happening. And that's the reason why Amazon is not paying any taxes. Pretty much they reinvest everything that stays out of that profit sharing kind of thing through stock in R&D. So that's what they do. They spend lots of money, and that money is well spent, right? Because they provide good service to clients. So DeepLens is about computer vision applications that you can build right away. So it has very tightly integrated links with SageMaker, so you can get machine learning. You can install on that DeepLens device. We're going to talk about this shortly. Recognition, it's not misspelled. That's how they do it. Looks like it was done on purpose so that people would kind of to get people's interest. And Lambda. So Lambda are those serverless architectures that you should use. So look at the Lambda whenever you want to cut on your bill. Okay, DeepLens is not supported in all regions. So things might change. This is quite fluid. So what is involved? You set up projects, and those projects you go through AWS Console. You would need a device, and that device is not anything that you can use. This device is something that you can buy, and guess from where? From Amazon. That DeepLens is pretty much a computer. It's highly programmable device. More on that in a moment. It's secure. You need to install this software. It comes with the pre-built software, but you can push software out there. So what models you can use? I guess that's back to the question from Surav. So as you see, you've got all those things. MXNet, which is something that is supported by Amazon, TensorFlow. I guess you are better off to use Keras on top of that. Okay, so an external models can be obtained through S3. So that's what the DeepLens device look like. It's on your right. It's pretty much, if you, I guess, open the box, you will see that it's just very nicely packaged, ODM hardware designed, original designer manufacturer. So AWS provides specs. And you have 8 gig of RAM. It's kind of a Raspberry Pi, if you will. The camera supports motion, so you can have security enabled. It has external USB ports, HDMI, so that you can, I guess, plug in. For USB, you can plug in your keyboard and HDMI monitor, and you've got yourself a very nice computer to play on. So it's lifetime support from Ubuntu. It's a camera pretty much, very highly programmable, robust. I guess in terms of pixelization, it's not good. Probably you can ask for something more expensive, but I guess it should probably go very well with memory and the CPU. It's Atom processor, which is kind of good, but probably not very good. So the expectation is, so you understand how all those things fit together. Okay, so that's a good question, and that's a use case for DeepLens. So you've got Amazon Web Services, that's the cloud. There is an interface called the Internet of Things. There's a trigger lambda. Essentially, it's an endpoint that you expose, and your device, which is deployed on-premise. In this case, it's a use case about bank branch. So this use case is covered by, there is, I guess, community projects for DeepLens, and you can, I guess, borrow on those ideas. It's, I guess, free of charge. People just want to showcase what they can do. So essentially, you have some infrastructure on the right, but things, the actual game, the actual action happens inside your branch. So it happens, this guy, a happy guy, walks in, and probably this guy would like to withdraw some money, right? So before this guy even approaches the counter, we can recognize the customer picture, and it can come from the backend, or it can be stored somewhere on premise. And inside this device, that machine learning is running. Pretty much, it would perform. It would go through all the tags. It will identify the client, and you can have the data on premise, or you can have the data about the client in the cloud, so that you just provide a customer ID, which is associated with this image, and you pretty much pull out all the data, so that by the time the client approaches the counter, you pretty much can welcome this gentleman by his last name, and probably already know what the person wants. Okay, so there's a question, does the device fall in the category of IoT? Yes, it does. Internet of Things, it can be anything. It can be sensors, but this is another thing. From the point of view, if you look at, if you put yourself in the shoes of that IoT gateway, and you look at as a source of this request, it's indistinguishable from any web service call. It would be a RESTful call, right? It would be HTTP, and it would be coming over SSL, that's for sure, and end-to-end protection. Yes, it is. Okay, so it's a good example. And by the way, you would immediately come up with something practical, saying, okay, I can do it at home. Who came so that you can greet the person. If it's Santa Claus, probably you can capture this as well. So Lex, so we talked about SageMaker, we talked about Comprehend, DeepLens, Lex. Okay, we're not going to cover all the services, we don't have time, but generally, I guess those services are something that you can start, I guess, looking at and benefit from. So Lex is a way to provide conversational interfaces. It's those bots that can be quite sophisticated at building natural processing NLP system. And probably you got the idea. Lots of things like Comprehend, Lex, and Alexa, all that stuff. It's about a big neural network which has been already trained, and you've got the big model probably spanning some several gigabytes of data, maybe even terabytes, sitting somewhere, and you pretty much like sending a request, and there are some embeddings for every of your requests. It does a quick lookup. It looks, pulls out the data, and it performs some enhancement of the response, and voila, you've got the output. So it's scalable. It supports a number of things, like integration with your clients can be anything. And there would be an example, I believe. Just give me a second. No. You, I guess, be able to build some very intelligent chats. So a client would submit a question. It can be over kind of a voice, or it can be text. And the system would have some predefined kind of a state machine serialized. And it would know intelligently, by the way. Lots of, you would say, I would like to make an appointment for tomorrow. And the system would know, or maybe 2 weeks from now, or I would like to do this and that. The system would be quite intelligent in translating your commands into the context of, it's not, definitely, it's not human, and humans should be safe for maybe a couple of years in many cases. So it's not smart enough, but in many cases it's good. If you are submitting a complaint or you would like to have a kind of a smart orientation or direction where I should go, rather than kind of a push one. If you would like to talk to our sales representative, it should be probably more informative. The person would probably complain about something, and you would be able to program using Lex the workflow such that it would be going directly to that. I don't know. Let's say it would be John Doe. Who would be responsible, ultimately responsible. Of course, the client would not know, but you would be able to directly, smartly to that particular person. So lots of things is possible. It's still in its infancy, and it's probably has lots of kind of redundancies. But I guess things are moving, and definitely it's worth exploring. Again, when you see Lambda, that means you have a way to cut on the cost. Poly is a way to convert text to natural sounding speech. That is an example, a slide. So what it does, it offers you a number of choice of voices, female or male, in a number of languages. And based on the text that you submit, it will synthesize or generate audio, which you can capture in any of the supported formats, MP3 or OGG, and you can stream it, download it, and use it. I guess many, US airlines, they have started using Poly because that's exactly sounds what you can hear. It makes very nice announcement in a very slow voice, no rush, we are good, just keep calm. And then it would be broken by the flight attendant who would be just pouring information on you like crazy. Okay, so very nice way to create very natural looking. You would probably be able to discern that it's not really a human voice, but when there is ambient noise and you are just interested in getting some information, Poly, I don't know why they call it Poly. Poly is just a nice way to do it. You can customize, you can essentially convert abbreviations into text. You can add some additional markers. It's kind of a HTML, XML type of thing where you can add pauses between words. You can add some simulated human breathing as if it's just a person is just catching breath. Okay, so lexicons, just flat files you upload, the system would use it for doing all that interesting stuff. So here's an example of that screen. Again, this is Amazon dashboard. Text to speech. Yes, there would probably be a question, is there a speech to text? Exactly, there is. And as you see, you can paste your text up to 3,000. If not, you can use, I guess, external storage. And at this point in time, I guess you will start paying for your service. SSML, that's lexicon where you would click on and you would be able to pretty much customize this page. Stage, you can slow down things, you can spell out things, you can read numbers, lots of interesting things, quite capable. Again, it's a good, ready-to-use product, so you don't need to use anything else. In terms of text-to-speech. That's the best of the breed, right? And many people probably have been using it. You can see on YouTube lots of things, just several slides, and there is monotonous voice, Poly's voice, reading what is on the slides. It's just a nice way to keep you to sleep. Okay, so you can get, you can listen through your computer mic speakers, or you can download it. As you see, for English US, we have quite a variety of voices. Okay, so that's good, and pretty much, I guess you can, if you know your audience, for example, what you can do, you know there is a problem, and there is you've got a feedback through comprehend that some people are extremely annoyed with something, and that's probably, let's say, it's a male, right? So if you kind of respond to that person using Matthew the male, probably that person would start really going out of I don't know, context. So if you, I don't know, provide feedback from, I don't know, maybe Ivy or Joanna, probably things would slow down. So as you see, you can do lots of variations on this type. So transcription, there is a question, poly, that is poly wanted kraken, okay, like a parrot. It parrots what is entered. Okay, poly wants kraken. Poly wants a kraken. Okay, good to know. Thank you. So transcribing is about, I guess, taking the actual voice, whatever Polly just told you, and you can transcribe it back into text. But the good thing with transcribe, it's quite fault tolerant. It can transcribe. Transcribe means it just will produce text out of your speech. You can upload it and you can stream it. There is a number of ways to do and get the results back. What was said, who was saying, speaker identification. So if there are like several people, there will be a man one or female two, and I guess you can get the context. Google is catching up. They're trying to add this feature. They have similar service. So as you see, the telephony quality, like around 8 kilohertz sampling rate, meaning that it's quite noise resilient. So pretty much now, I guess, human resources in big companies, they would love it because pretty much, I guess, rather than listening to all those conversations that are happening, for phone calls coming out of the companies, they can pretty much transcribe everything and do the keyword search. It's kind of a interesting field. Okay, so that's it for transcription. What else? Yes, the algorithm marketplace that I mentioned, the primary, I guess, consumer for that thing is Lex, no, not Lex, DeepLens and SageMaker. So those algorithms, they have been tested and they're really interesting in terms of what they can do for you. Companies are trying to experiment with doing this software as a service, of kind of machine learning algorithm as a service, and look at the price. So you've got overview what it is. I guess Intel is interestingly participating in this market as well, offering some algorithms. You see there is a fulfillment option, the region where it's available, and fulfillment option, meaning that the target would be SageMaker. So those algorithms, they already I guess, compatible with how SageMaker would be able to plug it in and run it on its infrastructure. So as you see, software pricing is graded or is broken down on the training phase, inference, real-time inference. As you see, you need to have all of those at P3 large machines, which we talked about earlier. Training usually takes more horsepower. Inference or prediction is faster, but at this point in time, you will be paying money. Okay, trainings, I understand. Okay, we're not going to really make you pay through your nose. So you'll probably be paying a reasonable amount, $1 per hour. But when you start with inference, where you start really monetizing your program, they would increase the charge. So look at this part as well. So probably have some business analysts to go carefully analyzing through all those things. As you see, like SageMaker algorithm training requires a very large instance. That would be EC2 instances. And it takes like $17 per host. And usually there would be a couple of hosts, I guess. And so things are kind of becoming interesting. But again, if you have spent some time on premise, making sure that everything is cool, and you are satisfied with output, you have tested your data, and you don't have overfitting, you don't have all that, I would say, you have pretty much bias, variance, balance reached properly, and you are happy at this point in time, engage Amazon. Otherwise, you would be probably paying more than you should. And then, so this algorithm is about automatic image tagging. So that company, I'm not sure what company it is. Probably it's Intel, or maybe some other companies. They, I guess, downloaded as many images as they could, and they had some people helping with image tagging. Tagging means like labeling. As you see, there is a insert at the right bottom. The system will be able to identify entities who is on that picture, and the system would identify that there is a sky and it's probably good weather. Shoes are red, so looks like this is a nice guy with a dog next to the hydrant, right? Color is red, and in some cases it would be quite important, I guess, for security and otherwise. Okay, so that's it for, I guess, my discussion of so Web Agent is a class. It's a one-day class which goes beyond what we've just talked. Lots of hands-on labs, just an interesting experience for students. Okay, so that will be the time for questions. That's good that we went through pretty fast. Let me check if I have missed any questions. No, we're good, good. I see that people are jumping off the bridge.